students, from last class onwards we are discussing about motion. Okay, let us continue the same lesson. Okay, so in previous class we discussed about acceleration. So let us discuss about uniform acceleration. Okay, uniform acceleration. So for uniform acceleration, example is a falling ball. Okay, falling object. Okay, so falling ball is an example for uniform acceleration. Okay, so let us consider the ball is at the top. Okay, so it's a initial velocity is equal to 0. Okay, so this ball is falling. So what is the acceleration or uh, gravitational constant? A or G is equal to 10 meter per second approximately, exactly is equal to 9.8 meter per second square, right? So as okay, so for each and every second it is falling 10 meters. Yes or no? 10. Okay, so in 1 second it is accelerated to 10 meter per second, and in second first second this much, and in second 20 meter per second square, and third second 30 meter per second square. Okay, so when the acceleration is constant, then it is case of a uniform acceleration. So for observe, for each and every second it is increasing its velocity or its acceleration by 10 meter per second, means it is changing uniformly for 1 second 10 meter per second. So this is a case of a uniform acceleration. Okay, so a freely falling body, okay, or a ball is falling from a certain height is an example for uniform acceleration. Okay, so non-uniform acceleration example, car. See, let us consider an example, non-uniform acceleration. A car that is accelerating. Okay, imagine you are driving a car. Okay, increasing velocity is not same. Okay, not same. So in a practical situations, will not drive the car with the uniform acceleration, obviously. Yes or no? For 1 second will you drive only 10 meters or in a particular value? No, because it's not possible in practical cases, because traffic, you can consider the traffic turnings, everything, right? Okay, so car that is accelerating. Okay, so imagine increasing velocity is not same. Okay, so let us consider you are driving a car. Okay, at 0 meter per second. See, at 0 seconds the speed of the car is 0 meter per second. Okay, so after 1 second, okay, 1 second, the speed is, your velocity is 5 meter per second. Okay, in a second your speed is 15 meter per second. Third second speed is 22 meter per second. Third second. Okay, so try to use the formula of acceleration, that is A is equal to v minus u by t meter per second square, and try to find the acceleration. At first second acceleration is 10 meter per second square. Second that is equal to 10 meter per second square, and third second a is equal to 7 meter per second square. Use this formula and find the acceleration. So is this acceleration is uniformly changing? No. So that's why it is non-uniform acceleration. Okay, so always force causes acceleration, right? Yes or no? Okay, always force causes acceleration. For an engine, okay, force on an engine of a car. Okay, so how the acceleration, you can observe the acceleration when the force causes acceleration. Okay, so force causes acceleration. Okay, so force on an engine, we already observed three ways to accelerate a car, right? Okay, by engine, by brakes, and by changing its direction. Okay, so force of an engine on a car. Force of an, so force causes acceleration, force on engine on of a car. Okay, and earth's gravity, force of acceleration. Okay, so whenever we consider driving a car, then that is the case of a non-uniform acceleration. So let us derive the equations of uniform accelerated motion. Okay, equations of uniformly accelerated motion. Okay, so there are three equations. We'll derive the three equations. Okay, first one is v is equal to u plus at. Okay, so velocity time relation. Okay, so you know very well uniformly accelerated motion graph, right? Okay, so on y-axis we'll consider velocity and on x-axis time. So the graph is like this, you can see, right? Okay, uniformly accelerated motion graph, this is the standard graph. By using this graph we'll derive the equations. First equation is u is equal to v is equal to u plus at. This is velocity time relationship. Okay, second one is s is equal to ut plus of at square. Okay, this is position time relationship. Okay, third one is v square minus u square is equal to 2as. This is also position time relationship. So what are the abbreviations, or what are these v, u, a, t? Okay, let us consider. Suppose you are dropping a ball from a certain height. Initially the ball is at rest, right? So initial velocity u is considered to be initial velocity, and v the speed. So we considered the ball example, right? Here the ball is there, we are dropping a ball, initial velocity u, and before it touching the ground final velocity is v. So this is the time distance covered by this ball. Okay, suppose you are dropping a ball from a building, so the distance becomes the height of the building. Okay, so this is, yes, a distance, and how much time it is taking to touch a ground, that is time t. Okay, so these are the terms. V is final velocity and t is time. So before the going forward, let me ask one question. Time is scalar or vector? You have to answer me. Okay, so time is scalar or vector? It's a scalar, because we'll not say 30 seconds north or 30 seconds south, right? Time is scalar quantity. Next, yes is displacement, or you can say distance also, but in a bits you will get s means displacement or at the time. Obviously that is displacement, but in some cases you will take a s as a distance also. Okay, so next, all the terms covered, right? A is acceleration. So these are the terms which are related to these equations. Let us derive the equations. Okay, first equation. Okay, v is equal to u plus at. Okay, let us consider uniform accelerated motion graph. Okay, so all the equations will derive using only a single graph. Okay, so let us try to observe the graph very carefully. So on x-axis we'll take a time, right? Okay, on y-axis velocity. So actually the velocity versus time graph or uniform accelerated motion graph starts from 0, but to derive these equations we are drawing that graph from a certain height a. Okay, here the point B. Try to join these two x-axis. Okay, so here I am taking a point C. So this is a point D. So OA is the initial velocity and BC is the final velocity V. Okay, so this is time T. Clear? So here BC is equal to how much here? BC is equal to AO is equal to DC is equal to U, right? Because it's try to observe this is a rectangle, right? In rectangle opposite sides are equal, so AO is equal to DC. The both are is equal to initial velocity U. Okay, so AO is equal to DC is equal to U. Okay, so next BC is equal to V, final velocity. So BC is equal to, it's a sum of BD plus DC, right? Okay, BD plus DC. BC is equal to BD plus DC. So DC you know already very well, that is U. Okay, so BD plus U. BC is nothing but V. So V is equal to BD plus U. Here BD is nothing but, this is initial velocity, right? Okay, so this BD is a change in velocity, right? Yes or no? So BD is equal to change in velocity. So you know very well acceleration formula. Okay, right? Acceleration is equal to change in velocity by time, right? Yes or no? So here change in velocity is nothing but BD by time t. So acceleration we indicate with a. So BD is equal to how much here? BD is equal to at. Okay, substitute this BD value here. So V is equal to at plus u. Yes or no? We got the first equation, right? Okay, so V is equal to u plus at. This is a derivation of a first equation, that is velocity time relationship. Okay, so this is a velocity time relationship. Clear? So let us derive the second equation, velocity time relationship. So let us derive the second equation, that is position time relationship. Okay, position time relation. So saying graph, you understood the graph, right? So velocity versus time graph. So I'm see for uniform accelerated motion graph, these will start from 0, but I'm considering with a certain velocity, that is a. So this OA is a initial velocity, and these I'm extending this AB to here x-axis, so this becomes a final velocity. So I'm considering like this. Okay, so here in second equation, position time relationship, position is nothing but distance, right? Okay, so distance is equal to, so here the area covered by this velocity is equal to this total area we will get. Okay, this total area. So this total area is equal to area of triangle plus area of rectangle, right? Yes or no? Okay, so distance is equal to area of triangle plus area of rectangle. So area of triangle formula of into base into height, right, plus L into B. Okay, so here of into base is nothing but OC, right? Base is nothing but OC is equal to AD. So here triangle AD, base is AD and height BD. Yes or no? Next L into B. L into B. L means OC into DC or AD into AO also you can take. Okay, so AD into AO. So here AD or OC both are equal, right? So AD, in place of AD you can substitute T. Okay, AO U, and here AD again T into BD. I'm placing like that. So in a previous derivation we already find BD is change in velocity. So acceleration formula, by using acceleration formula BD we derived BD is equal to AT, right? Just substitute here. Okay, so of into T into AT, BD is equal to AT plus UT. So here of into AT square plus UT. So distance is nothing but, we already said, distance or displacement both are indicated with S. So S is equal to UT plus of AT square. Clear? This is second equation and this is a position time relationship. Okay. Next let us derive the third equation. That is also position velocity relationship. Okay, so same graph. Third equation, v square minus u square is equal to 2as. Okay, position velocity relation. Okay, position velocity relation, same graph. Observe velocity time. So I am taking at a certain height, means certain initial velocity. Okay, so here distance is equal to, let us see, observe this, AO and BD are parallel, right? Yes or no? These are straight lines, means parallel. Okay, so these are parallel means shall I consider this area as area of a trapezium? Okay, so here distance is equal to area of trapezium. Okay, so area of trapezium formula you already know, right? So distance I am indicated with S. So sum of parallel sides by 2 into distance between these two parallel sides. Parallel sides. This is a symbol for parallel. Okay, so sum of the two parallel sides. So what are the sum of the two parallel sides? OA plus BC, right? OA plus BC by 2. Okay, and distance between these two T. Yes or no? Okay, so OA is nothing but U and BC is nothing but V by 2. Okay, into T. See, from the first equation, okay, from the first equation, v is equal to u plus at. Let us find the t value. So v minus u is equal to at, and t is equal to v minus u by a. Okay, so from first equation we found t. Substitute here. Okay, so u plus v by 2 into v minus u by a. So a plus b into a minus b, a plus b into a minus b is equal to a square minus b square, right? So apply this formula. b square minus u square by 2a is equal to s. Okay, so send this 2a to here. Here it is dividing. If I bring this side equal to this side, it will multiply. So 2as is equal to b square minus u square. Got the relation, right? Okay, so v square minus u square is equal to 2as. Clear? So this is the third equation. These are the three equations of uniform accelerated motion. Okay, so in next class we'll discuss the problems and for which problem which equation we have to use. Okay, so everyone know these formulas, they by heart and they remember the formulas, but they don't know for which problem which formula they have to use. They don't know. Okay, so in tomorrow's class we'll discuss the problems and for which problem which equation we have to use. Clearly we'll discuss with the tricks. Okay, so if you miss any video of this motion, try to go to my YouTube channel or your school app. Try to listen each and every video. This lesson is very important, okay, for exam point of view, even for further classes. Okay, if you miss any video, try to go to my YouTube channel or you can listen the video from the school app. Okay, but cover each and every video. Okay, so homework timings, let us compulsory everyone watch the videos and try to do the homework. Okay, and tomorrow we'll discuss problems part. This class and tomorrow's class very important compared to the other classes of the same lesson. Okay, so try to don't miss the class. Okay, thank you.